So we've touched on poverty, we've touched on population. Now we'll go back to talking about urbanization. Ran Goldblatt from UC San Diego, where he is a postdoctoral fellow, will talk about mapping built-up land cover in Vietnam.
So thank you. In the next 15 minutes, I want to present a study that was also supported by the World Bank into mapping the built-up land cover and land use in one province in Vietnam, Ho Chi Minh City, and in which we evaluated the added value of the relatively new Sentinel satellites for urban research. Vietnam is the perfect case study to study urbanization. It is one of the most densest countries in the world, and it has been experiencing rapid urbanization processes. For example, its urban population increased from 20% in 1990 to approximately 34% in 2014, and it is expected to reach 45% by 2020. Now, these urbanization processes are also accompanied by dramatic changes in land cover and land use, and in the conversion of open spaces, green space, and agriculture areas into urban areas. Now, as we know, traditional methods to map urbanization include census counts, ground surveys, and cadastral maps that are often stored as digital and paper files. But since the 1970s, there are more and more satellites that constantly orbit Earth and collect data in different spatial, spectral, and temporal resolutions, and they allow us to track what is happening on Earth in close to real time. What you see here in the image is the expansion of Ho Chi Minh City from 1984 to 2016. This is based on Landsat imagery. In parallel, we are also developing different remote sensing methods that are designed to convert this data into meaningful information about Earth and allow us to understand how different types of land cover and land use are changing in the areas. So the objectives of this study was to evaluate different remote sensing methods to map built-up land cover and land use in Ho Chi Minh City, to evaluate the added value of Sentinel satellites, the European Sentinel satellites, for classification of built-up land cover land use, to map temporal changes in the built-up land cover and to understand urbanization processes in Ho Chi Minh City, and to evaluate whether the built-up land cover can be used as a proxy for economic activity and the distribution of the population. And the case study, as I said, was Ho Chi Minh City. Ho Chi Minh City is the largest urban agglomeration in Vietnam, and it is the national financial capital in the country. And again, it has been experiencing rapid urbanization processes. Its population increased, for example, from 3 million people in 1975 to more than 8 million people in 2015. So we say that there are many, many satellites that constantly orbit Earth and collect data, and the question is which satellite we want to use and for which application. And we heard today that we can use planet data, we can use digital globe data, but these are very expensive. So we wanted to see whether we can also use public available satellite imagery. We evaluated data from 3 types of satellites, Landsat, Landsat 8, as all of you know, Landsat is the longest running program for acquisition of satellite imagery. The first Landsat satellite was launched in the 1970s. Currently, 2 Landsat satellites are operating, Landsat 7 and Landsat 8. We use Landsat 8, which collects data in a spatial resolution of 30 meters and with 11 spectral bands. In addition, we also used data from the 2 Sentinel satellites, which belong to the Copernicus program of ESA. We use Sentinel-1, which collects radar imagery, and Sentinel-2, which collects optical imagery in a spatial resolution of 10 to 30 meters with 13 spectral bands. So you can see that in general, the spatial and the spectral resolution of Sentinel is higher than Landsat. And the question was whether we will also get better prediction of built-up land cover. We did the analysis in Google Earth Engine. Google Earth Engine is a cloud-based computational platform for planetary scale analysis. It consists of petabytes of geospatial data, both raster and vector data, and it includes many algorithms for supervised and unsupervised image classification. And I invite those of you who are interested to learn about this platform to join us tomorrow in the Google Earth Engine workshop, which will be given by Nick Clinton from Google and by me. So the question is, how do we convert this data from the satellites into meaningful information? And we heard that there are different unsupervised machine learning, supervised machine learning, semi-supervised machine learning. In this study, we adopted the supervised machine learning approach, which generally speaking, you use real examples to learn patterns in the input, and based on these examples to predict the classes of new examples. So the question is, where will you get this real example, or the ground truth data? In this study, we evaluated two types of ground truth data. One is GDLA, which is the General Department of Land Administration. It consists of 73,000 parcels, where each parcel is identified by a unique land cover land use. From this, we selected a random sample of 6,300 parcels. And in addition, we created our own hand-labeled examples with 16,000 examples. We categorized all the parcels from GDLA into three categories: not built up residential, and built up non-residential. I don't have time, but in general, you take, in supervised machine learning, you take the reference data, you train the classifier to learn the patterns in the input, and you predict the class of new examples. And the question is, how do you estimate the accuracy of the classification? So usually we take the data, we divide it into two groups, training and for prediction. We use the trained classifier to predict the class of the examples in the test set, and we evaluate the accuracy of the map. We found that with GDLA data, we achieve an accuracy rate of up to 82% in predicting built-up and not built-up land cover. And note that the accuracy of the prediction with Sentinel-1 and Sentinel-2 together exceeds the classification with Landsat 8 by 7%. Now, also, you can see that the classification with Sentinel-2 is a little bit better than Landsat 8, but when you add the radar data, then you really improve the classification. Now, the problem with GDLA data, the parcel-based data, is that you have a lot of class noise, meaning that a polygon will often consist of different classes, mixed classes. So we also created our own hand-labeled points, which we labeled as not built up residential, and built up non-residential, and you can see that here we achieved an accuracy rate of close to 96% in predicting built up land cover, and 78% in predicting land use, built up residential versus built up non-residential land use. Of course, we don't just want to evaluate the accuracy, we also want to create maps and to map the land cover and land use. And we found that also visually you can see the fine boundaries between built-up areas and not built-up areas. And when you zoom in, you can see that we're even able to identify individual structures, individual buildings. And again, this is with Sentinel-1 and Sentinel-2. Public available. These maps show the distribution of residential and non-residential. In yellow, it's non-residential. In orange, it's residential. And also, when you compare the classification in high res, you can see that classification with Sentinel-1 and Sentinel-2 is more accurate than with Landsat 8. We also use the trained classifier to predict the built-up land cover in different moments in time, which allowed us to estimate the, how the city expands and to which direction. The last thing that I want to show is that we heard a lot about the nighttime light data, which is a common proxy for economic development and distribution of population. Here you can see the expansion of the city according to nighttime light data. We wanted to see whether our proxy, our built-up indicator is also correlated with nighttime light. We did analysis at the level of the district level, and we found very high correlations between the built-up land cover and population counts and nighttime light data. So, to summarize, remote sensing techniques can be utilized to map built-up land cover and land use. In this case study, we used supervised machine learning. We found that classification with Sentinel-2 exceeds the classification with Landsat 8 when they are used as input to the classifier. However, when we add Sentinel-1, the radar data, then we really improve the performance of the classification. And classification with GDLA, classification with, in Israel, it would mean that you have to go to the shelter. And classification with GDLA data as reference can also results in relatively accurate classification maps of particular built-up land cover, not necessarily land use. And we also found that the distribution of the built-up land cover is highly correlated with the traditional measures such as nighttime light data and census data. Thank you.